Now we're going to use our sign chart again, but this time we are not just verifying the movement of a particle, whether it's moving backwards or forward. This time we're going to verify if that particle is speeding up or slowing down. And to verify this, we need to use our rule. The rule is when your acceleration sign and your velocity signs are both positive or negative, it is speeding up. And when the sign of your acceleration and velocity is different, positive or negative and negative or positive, then it's slowing down. Now here's my example on how to verify your motion using your sign chart. So I have here my function, velocity function, t squared minus 6t plus 8, and I need to verify if this object is speeding up or slowing down. So the first step is to find your interval using your velocity function. And you have t squared minus 6t plus 8. By factoring, we'll have t equals 2 and t is equal to 4. Now these interval will be for our velocity. And to use the sign chart using your velocity, since you have two values right here, you can have three intervals for your velocity signs. So for anything lower than 2, which is in between negative infinity and 2, you'll have a positive sign, because when you use 0 for your value right here, you'll have a positive number for your velocity, and this sign is positive. Therefore, your velocity sign for this interval will be positive, which means it's moving forward on this interval. Now for the second interval between 2 seconds and 4 seconds, we have a negative sign for our velocity, because when we chose 3 as our value for t, we have a negative 1. So that means this particle is moving backwards between 2 and 4 seconds. And for our last interval, we have v of 5. So I chose 5 for my function of t. To verify the sign, it gives me positive 3. That's why I have a positive sign for my velocity for this interval. However, we're not answering the question is not about if the particle is moving forward or backward. The question is how or when it's speeding up and when it's slowing down. So we need to do an extra step, and the extra step is to find the acceleration. And after finding the acceleration, which is the derivative of your velocity, you will need to find the value of t for your new interval. And we have a new interval because we have an acceleration function of 2t minus 6, and t is equal to 6 over 2 by using the zero product property, and we have t is equal to 3. So this is our new interval that we will add to our sign chart. So we have now 2 seconds, we have 4 seconds, and we have 3 seconds to verify for acceleration. So that means on our second sign chart, we'll have 1, 2, 3, 4 partitions or 4 intervals. And we're going to have our new sign chart on the other side. And this is our new sign chart with the acceleration and the velocity sign for our function. Now we have verified the velocity sign already, and if you'll notice, I have 4 signs here instead of 3 because we had a partition for our interval for our acceleration function. So we have positive, negative, negative, positive for the signs of my velocity. For these interval, I have interval from negative infinity to 2 seconds, interval for 2 and 3, interval for 3 and 4, and interval for 4 and positive infinity. And just like what I did for velocity, I'm going to use my acceleration function and choose a number that is included in our interval. So for the first interval, I chose 0 because it's lower than 2. And after using 0, I have a negative 6 for my result. So that means this sign or the acceleration sign for this interval is negative. And for my second interval between 2 and 3 seconds, I chose 2.5 because 2.5 is in this range, and I have a negative answer for my substitution. So that means the acceleration sign is negative between these two intervals. And for the next interval, between 3 seconds and 4 seconds, I chose 3.5, and I have positive 1 as my result, so therefore this is a positive sign. And for my last interval, I chose 5 because 5 is higher than 4 seconds, and I have 4 as my answer, so it means it's positive. Now, to summarize our new signs, we can verify if the movement is speeding up or slowing down by the combination of your velocity sign and acceleration sign. So for the first interval, For negative infinity and positive 2, it's slowing down because the sign of velocity is positive and the sign of acceleration is negative. So it's slowing down for this interval. For the second interval, it's speeding up because it has the same sign, both negative. So between 2 and 3, the particle is speeding up. And between 3 seconds and 4 seconds, the particle is now slowing down because it has different sign. So it's slowing down for this interval. And for our last interval, for 4 to the positive infinity, we have same sign, which is positive. So that means this particle is speeding up. And that's how we use our sign chart in verifying the speed or the movement of a particle, if it's speeding up or slowing down. Now in this example, we have an equation in motion and we need to answer these 3 questions. So the equation of motion of this particle has an equation of s equal 2t cubed minus 7t squared plus 4t plus 1, where s is measured in meters and t is measured in seconds. Let's answer problems A, B, and C using our function. So let's find the velocity after 3 seconds. For B, the acceleration after 1 second. And for C, with what velocity is the particle at rest. So for letter A, it's pretty simple because we just need to find the velocity. And we know that to find the velocity, we just need to take the derivative of our function. So we have the derivative for our function, which gives us 6t squared minus 14t plus 4. And plugging in the value of 3 in our function, we verify that this particular particle has a velocity of 16 meters per second after 3 seconds. Now, to answer letter B, to find the acceleration after 1 second, we just need to find or to get the derivative of our velocity function for our acceleration. And it gives us 12t minus 14. And after finding the acceleration function, plug in the value of 1 for 1 second, and you'll have negative 2 meters per second squared. So this is our acceleration for this particular particle in motion after 1 second. And the last question, the velocity of a particle at rest. To answer this question, you will need your velocity function because the question is what velocity of this particle will that particle be at rest. So given 6t squared minus 14t plus 4 as our velocity function, you just need to find the values of t by factoring. So we can factor it out and we'll have 3t minus 1, t minus 2, and 2 as a factor of our velocity function. And using zero product property, we can find the values of t for each factor. So we have t equals 1/3 for our first factor and t equals 2 for our second factor. Therefore, to answer letter C, the particle is not moving at t equals 1/3 second or at t equals 2 seconds. And this is how we answer questions given the function of your rate of change.